Okay, okay, good. Chalo, so I take you back. Today we are having too many hiccups. Okay. Now I bring you back. We had studied last year, last class, that this natural gas. It's a fossil fuel. Okay, it's a fossil fuel which we get naturally under the earth. Okay, and it takes millions of years for the dead plants and animals to form into coal, crude oil, and natural gas. So here we are using natural gas, which is a fossil fuel, and on burning the water inside it, you can see that bubbles are rising. Okay, you can see that the bubbles are rising, which means heat is getting transferred to it. Okay, so when fossil fuels, when they burn, when they combine with oxygen, okay, burning means when they are combining with oxygen, okay, then they transfer energy. And in this case we see that this energy is being transferred to the water. And we had discussed in the previous class that fossil fuels are classified, the energy they contain is classified as chemical energy, the energy which was trapped inside them for millions of years, and now when we burn them, this energy is released. Okay, in the last class, okay, you want to start it again? Okay, we start again. Chalo, we start it again. Okay, today we are going to study about the transfer of energy. The topic is moving it around. Okay, the topic is moving it around, and we'll talk about the transfer of energy. So now electricity, that is current, electric current, is a way of transferring energy. Okay, it's a way of transferring energy, and it transfers energy to your house. Okay, and now you are using this energy to run your fan, to run your refrigerator, your television, everything. Okay, now you're using this energy to run all the electrical appliances which are present in your house. Okay, now electric current is not the only way in which energy can be transferred. It can be transferred by heating also. It can be transferred through forces also. Energy can be transferred through sound also, and energy can be transferred through light and infrared radiations. Okay, we will discuss all these in detail one by one. We start by studying transfer of energy through heating. Okay, beta, clear till now? So we use fossil fuel. Okay, here you can see that the gas is lit, and I have a pan with some water on the gas stove. Okay, so this natural gas or compressed natural gas also is a fossil fuel. When we burn fossil fuels, okay, fossil fuels are energy resources, which means that they are a store of energy which can be used in a useful way. Anything which is useful to us is known as a resource. Okay, so fossil fuels are a energy resource, which means they are a reserve of energy which can be used by us in a fruitful way. So these can transfer energy when they combine with oxygen, that is when we burn them. Okay, whether it is coal, whether it is petroleum, whether it is compressed natural gas, we burn all these things and then they release the energy which is stored in them. Okay, now the energy which is stored in these fossil fuels, whether it is coal, whether it is petrol, whether it is compressed natural gas, all of them contain chemical energy. Okay, the energy stored in them is known as chemical energy, which can be used in useful form. Now we use, last time you only had told me, okay, that your energy comes from food. Same way, everybody, every human beings, every living thing's energy comes from food. Okay, so food also is a form of chemical energy. Okay, we eat food, and the chemical energy which is there inside the food. Last time you had replied carbohydrates, I remember. Okay, glucose you had said. Okay, so this the food also contains chemical energy which is taken up by our body and used to do the different things that we do, right? Then cells, you must have seen a cell inside your mobile phone. Okay, you must have seen cells inside your remote control. In some of your toys also may contain cell. Okay, so these cells also are man-made, okay, stores, chemical stores of batteries. When your mobile is low on power, then you put it for charging, right? So what is happening over there? The electrical energy changes into the chemical energy of your battery, and then when you are using the mobile, then this chemical energy is turned to do the different functions of your mobile. So understood the stores of chemical energy? Now, can you name some of the chemical stores of, some of the stores of chemical energy? Now I'll wait for some time. In case you have some query, you can ask. Otherwise, I wait for your answer. I want some names of stores of chemical energy, and then we move on. Waiting for your answer. Okay. We discussed so many just now. Okay, we discussed so many just now. The food which you eat. Okay, let me change the color. Then I'll erase all this and then I'll underline it with a different color. Okay. Now this one. The food that you eat. Okay, the food that you eat is a source of chemical energy. Okay, then fossil fuels like coal, okay, compressed gas, okay, all these natural gas, all these are source of chemical energy. Then the battery or the cells which we have made also are a store of chemical energy. Clear, beta? So your food is source of chemical energy, store of chemical energy. Fossil fuels like coal, petrol, natural gas are stores of natural energy. And of course, the batteries or the cells that we use, they also are stores of natural energy. Understood now? Food, fossil fuels like coal, petroleum, natural gas, and batteries or cells, all are stores of chemical energy. Understood, Rishika beta? Okay, so we proceed now. Okay. Now when fossil fuels burn, okay, when fossil fuels burn, then they transfer energy as heat. We just talked that energy can be transferred as heat, okay, by heating. So when fossil fuels burn, they transfer heat. Now we look at this photograph, okay. Here natural gas is burning, okay, down under the pan over here you have natural gas which is burning, okay, and the energy stored in this natural gas is transferred. Inside you can see bubbles rising, okay, you can see bubbles rising. So the inside this energy now is transferred to the water in the pan, okay. So now the water, initially it was cold. Now how does it feel? Now if I touch the water, it's hot. Okay, it's boiling hot. It can do a lot of damage also to me. So now this water has a store of thermal energy. Okay, so what is thermal energy? Energy in the form of heat is known as thermal energy. Anything which has a higher temperature, which has heat stored inside it, is said to have thermal energy inside it, right? Like this boiling water over here has thermal energy inside it. And from where has this thermal energy come? This thermal energy has been transferred to it by this natural gas which is burning under it. Okay, clear till this point? Okay, now the energy which the compressed natural gas has transferred, has all of it been used by water? Has the entire energy which was transferred by compressed natural gas, has it been used up by water? Has the entire energy has it been transferred to water? Tell beta Rishika. Okay, no, it is not, the entire energy has not been transferred to water. Why? Because water is contained in a pan, okay, and the pan also gets heated up, okay, which means some energy has been taken by the pan also, and then we have the pan is surrounded by air. Got it? So this air also becomes warm, which means some energy has been transferred to the air also around it. Got it? This is known as dissipation of energy or wastage of energy. Okay, there is always wastage of energy. We say that energy is conserved, okay, which means it can neither be created nor be destroyed. It just changes from one form to the other. What change are we watching in this case? What change are we watching in this case? Okay, beta, understood? So the entire energy has not gone to water. Some of it has gone to the pan, some of it has gone to the air surrounding it. Got it? So some energy is being wasted. I asked you what energy change is taking place in this case. What energy change is taking place in this case? The case which we discussed, the pan full of water heated by natural gas and the water starts boiling. I said that when the water starts boiling, now the energy that it has is known as thermal energy. Okay, so the heat energy which a body stores is known as its thermal energy. So in this case, I say that energy transfer has taken place. Can you please tell us which energy has changed to which other form of energy? Very nice. Thermal energy. It has changed to thermal energy. Which energy has changed? You're correct. It is thermal energy. Okay. But what has changed? The chemical energy. Where was the chemical energy? The chemical energy was in the natural gas. And now this chemical energy has changed into thermal energy. Perfect. Understood? So we move forward. Okay. We'll come back to this picture. Now we have some questions over here. Write down 3 things that transfer energy by heating or light. They are asking us to write down 3 things that transfer energy by heating or light. Okay, you can see here we have compressed natural gas, okay, then which transfers energy by heating. Then we have petrol, which transfers energy by heating. We have coal, which transfers energy by heating. Then they say or light. So we have sun, which transfers energy by light, right? Clear? Then they are asking us to write down 3 things that transfer energy by sound. Can you tell me any thing which transfers energy by sound? Think in your everyday life. It's easy. Can you remember of an example where energy is transferred through sound? Okay, I'll tell you. See, now when I hit hard on a drum, then whatever energy I had, now that energy is transferred to the surrounding in the form of sound. So that becomes sound energy. You ring a bell and the energy is transferred to your eardrums in the form of sound energy. We burst a cracker, again a lot of energy. Sometimes the window panes also shatter if it's a very powerful explosion. Okay, so all these are examples of transfer of energy by sound. Okay, now this is an easy one. The last one, they say use energy transferred by electricity. That when we started the topic today, then itself I said that whatever you are using a laptop, it is using electricity that has been transferred to your house. A light is glowing in your room, maybe a tube light or LED bulb. Okay, again it is using electricity which has been transferred. Fan is running, which is using. So there are all the devices which we use, the oven, the microwave, everything uses energy transferred by electricity. Okay, so we have already discussed this question. 4 things that are store of chemical energy. Biomass. What do you mean by biomass? We had discussed this in the previous class. What do we mean by biomass? We say that biomass is a store of chemical energy. We have already discussed petrol, coal, natural gas and chemical batteries. Okay, let's discuss what is biomass. We say that biomass also is a store of chemical energy. So what's biomass? What's biomass? The total quantity or weight of the organism in a given area or volume. Okay, you're talking about mass. This is the correct definition of mass. Okay, so if it comes from living thing, okay, bio means living, like cow dung. Okay, cow dung comes from cows, a living thing. So cow dung is biomass. We can use cow dung to make gas which we can burn. Okay, we can make cow dung to make cow dung cakes, which again are used to burn. Okay, so then twigs and leaves that have fallen off a tree, they were part of a living thing. Now they also can be used to burn. Okay, wood, it can be used to burn. So all these things which come from a living thing are known as biomass, and they also are a store of chemical energy, right? Because after all, the living thing must have received directly or indirectly energy from the sun, and now this energy is trapped inside it. So biomass also is a store of chemical energy. Clear, beta? Okay, 3 things that transfer energy by heating or light. We discussed electric bulb, coal, sun, okay, petrol. Then 3 things that transfer energy by sound. Here I had asked you this to tell me. Okay, now I explained already to you that whenever there is a loud sound, a band playing, organic matter is used, especially in a power station, for very nice. Okay, is biomass. Okay, now we are talking about transfer of energy. Perfect answer. Now we are talking about transfer of energy by sound. Okay, so you must have seen that when you switch on a radio, okay, there is transfer of energy. The energy is converted into sound energy. Electrical energy is converted into sound energy, and now your ears can feel it. Similarly, the telephone, the mobile, okay, they also transfer energy in the form of sound energy. When a horn is sounded, we blow into the horn, and now the energy is spread to the surrounding in the form of sound. Okay, we ring a bell, and the energy which we put into the bell is transferred to the surrounding by the ringing of the bell. Correct? So we've discussed all this. We've discussed the appliances also used. Now we go to energy that can be stored in other ways. At present we have talked only about fossil fuel and chemical energy. Okay, and let's discuss this diagram B first. Okay, now when we were heating the pan, the energy, chemical energy stored in the natural gas, okay, we said that some of it went into the water. Okay, so it became the thermal energy of the water in the pan, right? And some of it was wasted in the sense that it became the thermal energy of the pan and the air around it. Okay, so it was not useful to us in any way. Got it? So we can depict this by a diagram which will go later in the chapter. At present we go to other forms of energy. In this we need to understand that the whole of energy transferred, energy is conserved. Okay, whatever energy was there in the natural gas, the entire energy has been transferred, but the entire thing has not been used usefully. Okay, only some part, say 60% of has been used usefully, because we have been able to convert that 60% into thermal energy of the water in the pan. But the rest 40% energy, it has been dissipated, it has gone a waste, because it was spent in heating the air around the pan, which is of no use to us. Got it? Or it was used up in heating up the pan. Okay, so now we go back to energy that can be stored in other ways. Okay, we have got nuclear energy or atomic energy. Do you have any idea about nuclear energy or atomic energy? What is it? Okay, don't worry beta. Now see, I'll tell you, whatever matter is around you, okay, it is made up of atoms. Now atoms are made up of 3 further subatomic particles. Okay, now if I look into an atom, it looks somewhat like this. Okay, it has got a nucleus which has got neutrons and protons inside it. Okay, and then it has shells in which electrons are revolving around it. Okay, electrons are negatively charged excuse me, protons are positively charged, and neutrons are neutral. Okay, so they have got different shells, and now in these shells electrons revolve around the nucleus. Okay, you pick up any matter, it will be made up of atoms, and all atoms will be like this. Okay, the number of protons and the number of electrons and neutrons is different in atoms of different matter. That is the only difference. Otherwise all of them have a nucleus containing the neutral particles neutrons and the positive particles protons, and then they have electrons revolving around them. Okay, and we know that positive charge attracts negative charge. Okay, that's why these electrons don't fly away, because they are constantly pulled towards the nucleus by the positive charge of the protons inside the nucleus. Got it? Now what happens when the number of neutrons is high and the number of it's a heavy nucleus, which means it has quite a large number of protons, then they break down. There are substances which are known as radioactive substances. They keep on decaying. They break down into smaller nucleuses. They break down, they form new elements which have lighter nucleus. Okay, so a heavy substance like uranium, which has a heavy nucleus, it breaks down into smaller elements which have lighter nucleus. Okay, and now I said that these electrons are being attracted by these protons, so there is a potential, there's potential energy. Okay, so when there is a breakdown, then this energy is released. Okay, and now since this energy has come from the atoms because of the breaking down of the nucleus, hence it is known as nuclear energy. and because it has come from the atom, so it is known as atomic energy. Okay, the procedure which I talked about is known as nuclear fission, which means one big nucleus breaking into two small nucleus with a lot of energy being released. You'll study these in higher classes. At present, I want you to just to get a general idea. Okay, if somebody asks you what is nuclear energy, so nuclear energy is energy which is released from the nucleus. Okay, it could be because of two reasons: either nuclear fission, which means a heavy nucleus breaking into two smaller, lighter nucleuses, or it could be due to fusion, when two light nucleuses combine and form one heavy nucleus. Got it? Now, this property of matter is used, okay, by power station. You must have heard about nuclear power plants. Okay, in these nuclear power plants, they use this energy which is released on fission of nucleus, okay, and they convert it into electrical energy. Okay, nuclear power stations can transfer the nuclear energy inside atoms of metals such as, I told you, uranium. Okay, uranium has a very heavy nucleus, so it can easily break down, and then they use this energy to produce electricity. Clear? Okay, substances like uranium with heavy nucleus, they break down into smaller nucleus and they release a lot of heat energy. This heat energy is used to produce electricity. Okay, very nice. You say yes. So we move forward. Okay, now the sun, I told you in the previous class that the sun is the ultimate source of all energy. Okay, so from where does the energy in the sun comes that it is able to radiate across the whole universe? Okay, now on the surface of sun also nuclear fusion is taking place. Okay, so actually the sun also gets its energy from nuclear fusion. Okay, they are light atoms of hydrogen combined to form helium with a release of lot of energy. The mass of the product is less than the mass of the reactants. Again, this you'll study in the higher classes. Okay, so whatever mass is lost, that mass is converted into energy. So because of nuclear fusion on the surface of sun, a lot of heat energy is produced. You can see the sun burning, isn't it? And now this heat energy is radiated to far away distant planets like the earth. Okay, and it is transferred as heat as well as light. When the sun is out, you can experience light. Yeah, correct. So the energy which the sun sends, we use it as solar energy. Okay, the sun transfers energy in the form of heat and light, and of course we can use this energy. It's coming from the sun, so we call it solar energy. Clear? So I am sure you must have understood what is nuclear energy. You must have understood how the sun, from where the sun derives its energy from. Okay, and now we move on to something known as kinetic energy. Okay, do you play cricket? Do you play cricket or some sport, some other sport, football, hockey, or badminton? Do you play some sport? What are your hobbies? Tell me about your hobbies. I'll tell you mine. Now, if a ball is lying near the wickets, okay, I have a ball over here which is lying next to the wickets. I have a ball which is lying next to the wickets. Does it do anything to these wickets? Okay, you play cricket. Nice. So if you play cricket, now there's a ball which is lying next to the wickets. Is it going to do anything to the wickets? Is it going to shatter the wickets? Is it going to disturb the wickets? No, it's not going to do. Okay. Now I throw it. Okay. I use my hands and I throw this ball now towards the wickets. Now are they going to do anything to the wickets? Now is the ball going to do, is it going to shatter the wickets? Is it going to disturb the stumps? Okay, very nice. Singing, dancing, drawing, swimming, very nice. I am good at drawing. I am good at painting. I am good in drama. I am a cricketer. Okay, so we share a few things. I do swimming once in a while, not very often. I don't get enough time for swimming. So I do know swimming, but I don't swim very often. Of course, I love drawing. So that's a common hobby which we have, and of course we can look into each other's artwork. Okay, we can share each other's artwork. In case you need some help in drawing, you can always tell me. My son is pretty good at drawing. Okay, he makes animated characters also. Okay, so we come back to the question. When I throw this ball towards the wicket, now is it going to disturb the stumps? Initially the ball was lying just next to the wickets, and then Rishika says that it's not going to disturb the stumps, and you are absolutely correct. Now I say, now I throw it. Now I throw the same ball towards the stumps. And now are they going to disturb the stumps? Are they going to shatter the stumps? This time they'll shatter, beta. I am thrown them towards the stumps. So if they hit the stumps are going to fly away. Okay. In the previous case, the ball was just lying next to it. So the ball didn't have any energy in it. It was lying next to it. So in the previous case, of course, it was not disturbing. But this case, it is disturbing. Why is it disturbing? Because it has got energy. Okay. Energy by virtue of its motion. So moving objects, are stores of energy. Anything which is in motion has energy inside it, and this energy is known as kinetic energy. Okay, energy by virtue of motion. So this ball was stationary. So it didn't have any energy, but this ball is in motion. Okay, so it has got kinetic energy inside it. Got it? And this kinetic energy will be transferred to the stumps, and hence the stumps start flying away or rolling away when it hits them. Right? Now suppose, let me erase all this and then I talk. Now now the same stumps, and you and I both are throwing the same kind of ball. Okay, suppose it's a cricket ball. You also are throwing a cricket ball. I also am throwing a cricket ball. Okay, now when you throw and it hits the stump just moves a little away. Okay, because you're a small child, you don't have that much strength. On the other hand, when I throw the stump, okay, I throw the ball, the wicket goes flying away. Okay, the wicket goes flying away. What is the difference? The difference is that I have more strength, so I threw it with a greater force, okay? Which means the ball which I threw was traveling faster. So the faster the movement, the greater the kinetic energy. You can see that when you threw the ball, the stumps just fell down. But when I hit it, there it goes flying away. So what was the difference? I threw it faster, which means the ball which I threw had greater kinetic energy. Understood, beta? So the faster the body is moving, the greater kinetic energy it has. Understood? I revise once again kinetic energy, okay? Kinetic energy is the energy possessed by moving bodies, okay? Anything in motion has kinetic energy in it. Then the second point which we have understood is that the faster the motion, the greater is the kinetic energy. If something is moving slowly, it has less kinetic energy. On the other hand, if something is moving at a very great speed, it means that that thing has a lot of kinetic energy. Okay? Clear? Now that you have understood kinetic energy, we still have some time. I'll finish this page at least. Okay, we go to potential energy. We go to potential energy. Okay, what is potential energy? The energy which is stored inside a body. Okay, the energy which is stored inside a body. And how is it stored? It is stored because of its change in shape or because of its change in position. Okay, is known as potential energy. For example, just a minute. Okay, for example, okay, I have this thread in my hand. Okay, I fix it between my fingers, okay, and I pick up a piece of paper. Okay, I pick up a piece of paper. Now what I do is I put the piece of paper over here. Okay, I put the piece of paper over here and I pull it. Okay, I pull it. So you can see that I have changed the shape of the thread. Okay, as soon as I release it, the paper flies away. As soon as I release it, the paper flies away. Had it been a rubber band, it would have more elasticity, it would have flown further away. Okay, as soon as I release it, the paper flies away. So when I pull this thread, you can see the picture of bow. You can see the picture of bow on the screen, right? Now the bow works on the same principle. Okay, the bow works on the same principle. Okay, I've got a slingy over here. Okay, I've got a slingy over here. I pull it. Okay, I pull it, and as soon as I release it, I have changed its shape, right? As soon as I release it, you see it flies back. I pull it, I've changed its shape, and I release it, and then it flies back over there. Got it? So when I change it, this is known as elastic potential. Okay, this is known as elastic potential. I've changed the shape. Same with the balloon. You press a balloon, okay, place something on it. Okay, as soon as you release it, it flies away. Got it? The bow and arrow. I pull the string. Okay, I have changed the shape of the elastic of the bow. Okay, and as soon as I release it, the arrow flies away. Got it? So this is elastic potential. On the other hand, there is something also known as gravitational potential. Okay, now this is a cube which is lying over here on the ground. Okay, I lift it. So I have changed the position. Okay, this is 0 level and I have done some work to lift it up to this level. Okay, so now this has potential energy in it. Okay, as soon as I release it, there it flies down. Now the energy was changing into kinetic energy. It gave it motion. Okay, so this one is known as gravitational potential, and the one which we discussed earlier, the bow and the arrow, the spring, okay, the rubber band, the balloon, all that is known as elastic potential or strain energy. Okay, so we have studied chemical energy, we have studied nuclear energy, we have studied kinetic energy, and now we are studying potential energy and the types. The first type of potential energy is elastic potential energy, also known as strain energy. Okay, now this strain energy, as I've already shown you, is stored like the bent bow, the stretched spring, the twisted or squashed bottle, or the balloon. Got it? So when you change the configuration, when you change the shape, then because of the change in shape or because of the change in position, whatever energy is stored inside the body is known as its potential energy. Okay, understood? Now we also discuss gravitational potential. Anything which is at a higher position, like I raise the cube to a higher position, okay, when it goes to a higher position, it acquires gravitational potential energy. Because what is gravity? The gravity is the force by which earth pulls everything down. So if I have done some work against this gravity to raise it to a level, that energy gets stored in the body, and as soon as I release it, the body starts falling towards the earth. So at that raised position, the energy which is inside the body, which is stored inside the body, is known as its gravitational potential energy. Clear? That's all for today. We'll continue from here. In the next class, we will do conservation of energy. Okay? You have anything to say to me? Please tell me. How did you like the class? Did you understand everything? In case you have any query, you can always write to me. Okay? You can WhatsApp to me and I will answer your query in the next class. Right? I'm waiting for your comments. I finish my class here itself.